Alright guys, today's goal, the learner will understand what parametric relations are and inverses. Okay? What you'll learn about defining relations parametrically, inverse relations, and inverse functions. And why some functions and graphs can best be defined parametrically while some others can best be understood as inverse of functions we already know. Consider the set of all ordered pairs x, y defined by the equation x equals t minus 1, y equals t squared plus 2. Find the points determined by t equals, okay? Alright, so what that means is we would plug in x equals negative 3 minus 1, negative 4. Y equals negative 3 squared plus 2, 11. Okay, it's asking you to get the x and y values based on t. So plug all those in, and this is what we would get. Okay? So that's how you could graph them. So this is the parametric where x and y are defined by a separate variable t. Okay? So we have this. Consider a set of all ordered pairs. Find an algebraic relationship between x and y by eliminating the parameter t. So this is what I would do. I need to get rid of t, so I need to find out what t equals. Pretty easy here. How would I solve this equation for t? Well, add the 1. So you get x plus 1 equals t. Now, go down. We already know this, but what can we substitute in for t? We can take x plus 1, bring it down, and substitute it in for t. Now remember, we need to set it up like this. It's not just square the first, square the second, guys. So you got to multiply it out. So you would get x squared plus 2x plus 1 plus 2. X squared plus 2x plus 3. Okay? So now we have the algebraic relationship. Okay. The inverse of a relation is a function if and only if each horizontal line intersects the graph of the original relation and at most one point. So remember the vertical line test, where if we had a graph something like this, you would do this, and then it was a function because it only intersected once. Now this is saying horizontal. So if that's the function, if that's the original function, the inverse of that, you go like this. See how this one hit twice? That means it's not a function. So the inverse of this would not be a function. Okay? Alright. If f is one-to-one function with domain and range, then the inverse of the function is denoted by f to the negative 1. Is the function with a domain of r and a range of d. Okay, so see how here this had a domain of d, but its inverse has a range of d, and this had a range of r, and the inverse has a domain of r, meaning the inverses, they flip each other. Okay, so we'll see some examples of this. Finding the inverse of a function. So we have f of x, I want to find the inverse. What that means is Start by saying y equals 2x over x minus 1. Then switch the x and the y. X equals 2y divided by y minus 1. Now you have to solve this equation for y. So first thing you got to do, multiply both sides by y minus 1. So distribute the x, so you get xy minus x equals 2y, because those cancel each other out. Now, I would subtract the xy over. So you get negative x equals 2y minus xy. Factor out the y. And then divide. So you get negative x over 2 minus x equals y. Okay? Or you could have also gone another way and you would have gotten x over x minus 2. So the inverse here is x over x minus 2. So you switch, to find the inverse, you switch the x and y, solve for y. A function f is 1-to-1 with the inverse function of g if and only if f of g of x equals x and g of f of x equals x. For every x in the domain of g. So let's see what this means. Show algebraically that they are. So first thing I need to do, calculate f of g of x. So that means f of the cube root of x minus 2. That's a mess. Let's erase this. F of cube root x minus 2 equals, plug that in then. So cube root x minus 2 cubed plus 2. Well, the cube root of x minus 2 cubed is just x minus 2 plus 2. So that equals x. So we're good there. Are there any domain restrictions on g of x or f of x? No. So we're good. Now we need to calculate g of f of x, which is g of x to the third plus 2. Plug it in. Cube root, well, what does x equal? X to the third plus 2 minus 2. Well, what's 2 minus 2? 0. So cube root of x to the third, x. So there we go. They both had check. So yes, they are inverses. See you guys tomorrow in class. Be ready.